Hi. You may ask what happened before the Big Bang. And of course, we don't know. We have a pretty good idea of what I said in the first video, but we really don't know what happened before the Big Bang, but we have some ideas. And to explain these ideas, I need first to explain tell you something about energy. So let's suppose we have a wire here and a ring that fits around the wire. And if we let that ring go, it'll zoom down and then go back up. And then when it gets to this height again, it'll come back down again. Come back down and zoom back up. If it's up here when we let it go, it has what we call potential energy. And when it's down here and it's moving really fast, it has what we call kinetic energy. And in fact, the amount of energy that it had here is the same as the amount of energy it has here. It's just a different kind of energy. And we know it's the same amount because this kinetic, as it moves, continues to move. This kinetic energy gets transferred into the potential energy, and it's the same potential energy as over here because it's the same height. And then it will stop. When it stops, the kinetic energy is zero. It falls back down, and the potential energy drops. Kinetic energy gets to a maximum, and then again the energy gets turned into potential energy. So the energy is conserved, but it can have these two different forms, potential and kinetic. Now here's what let me say something about quantum mechanics first of all. In quantum mechanics, anything that doesn't violate one of the fundamental laws of physics, anything can happen on a short enough time scale. And in particular, energy conservation and is something that is enforced only on a longer time scale. So, and what we call these well, as I was saying, on a short time scale, anything can happen in a short volume. And what we think, and these things are called quantum fluctuations. And so what we think happened before the Big Bang was that somewhere in an enormous empty universe, somewhere there was a fluctuation. And this was a big fluctuation. And a fluctuation of potential energy. So all of a sudden, in a very tiny region of space, the potential energy became enormous. And now one of the features of general relativity is that when potential energy becomes enormous, it has trouble going down. And this is something that can be called gravitational friction. And so that potential energy remained high in a certain region for much longer than it would have had general relativity not slowed it down. And during that time, because there was an enormous energy density there, that energy density caused that region to expand, just as for the last 3.5 billion years, the dark energy density has accelerated the expansion of the known universe. So what happened was this tiny region of space, which could have been big, but a tiny region of space expanded at an incredible rate. And when it expanded, then one had a huge region of very high potential energy. That region, after a very brief period of time, that region then was able to collapse into kinetic energy or radiation, and that was the Big Bang. I think we can stop here. How long was